10.2, products and quotients of functions. So this is the second last lesson of 30-1. So it starts off with a little bit of review. Cobalt-60, which has a half-life of 5.3 years, is used in medical radiology. A sample of 60 milligrams of the material is present today. What amount will be present in 10 years? Remember, it has half-life. So because the word half-life, we're going to use final equals initial, and then your rate to the T over the P. The time it takes to reach the final amount, and the period, the time it takes for it to half, double or triple. So cobalt-60, yay, who cares? We ignore that 60. It's just cobalt. 60 goes nowhere. Which has a half-life. So in for our rate, we have a half, or 0.5, of 5.3 years. So half-life of 5.3. That means the 5.3 goes on the bottom. And a sample of 60 milligrams is present today. So that's going to be our initial. And we want to know how long it will take, or what the amount will be, sorry, in 10.6 years. So we want the final amount in 10.6. And we plug that just directly into our calculators. So on, and we're going to have I always go, calculator just got big, 0.5 to the, make sure it's in brackets because it's a fraction, 10.6 divided by 5.3, enter, times 60. You can put it in all at once, but I like being careful. So the final amount is 15 milligrams. So that's units. Then we ask, how many years will it take for the amount of cobalt-60 to decay to 12.5% of its original? So we need to find out what 12.5% of its original is, because that'll be the final. So it's going to be 60 times 0.125. That's how you do it if you're trying to convert from percent. So we have 60 times 0.125. Remember, if you want to go from percent to decimal, you divide by 100, and you get 7.5. So the final is 7.5. So we have 7.5 equals 60, half or 0.5 to the T, we don't know, and the half-life time didn't change, 5.3. Now what I always say to do is divide that initial over. And then you can do the algebra of it, or you can go directly to your calculator and go 7.5 divided by 60, not rounded, equals 0.5 to the x divided by 5.3. Put that directly into your y1 and your y2. And then find out where they intersect to get your x value. So into our y1, I'm going to go, or you can do the algebra of this. You can convert it to a log from here and solve for x, which absolutely works. So 7.5 divided by 60. If you want to put that in brackets, you can, but because it's by itself, I don't have to. And then over here, I'm going to go 0.5 to the exponent. I like putting that in brackets. I'm going to go 0.5 to the exponent bracket. Now I have to put this in brackets because it's a fraction. And it's not just by itself. So x divided by 5.3, close bracket. That's my graph. Now if I go second trace 5, enter, 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 and it errors me, it's because you're trying to find an x value that's larger than your window can see. And if you can't see it on your window, it can't calculate it. So second trace 5, enter, enter, enter. Let's see what we get. So it says no sign change. Now that's because if I go to my window, my x max is 10, and the value of this is going to be more than 10. Okay, it took 10.6 to get to 15 milligrams on the previous examples. It's obviously going to be more than 10. So I'm going to try 30. Second trace 5. Let it draw my graph. Enter, enter, enter. And I get 15.9. 15.9 what? Well, this is in how many years they want. And remember our T and our PF being the same units, and it was in 5.3 years, so that's good. So x equals 15.9 or 15.9 years. Now you always have to check what your T and P values are in because they have to be in the same unit. So if one's in minutes, the other one has to be in minutes or vice versa. So now we're starting product and quotient. Product is always multiplication and quotient is division. So example number 1, for the pair of functions, determine h of x equals f of x times g of x. If they're sitting beside each other like that, that means multiplication. The other way they could be written is h of x equals f closed dot, because an open dot means something different in the next lesson, g of x. Now we never leave it like that. Remember, we're going to write it like how that one is, f of x times g of x. Okay? So h of x in this case is going to be f of x, which is x plus 3, times g of x, which is 2x minus 5. Then we're going to FOIL them. X times 2x is 2x squared. X times negative 5 is negative 5x. 2x times 3 is positive 6x. 3 times negative 5 is negative 15. So we're going to get h of x equals 2x squared. Combine these, you get plus 1x minus 15. Done. Example 2. Consider the functions f of x equals x minus 4 and g of x equals x plus 4. Determine the equation h of x equals f times g of x. Remember, if they're written together like that, you always want to separate them. So what they're asking us to find is h of x equals f of x times g of x. So it's going to equal f of x, which is x minus 4, times g of x, which is x plus 4. And we're going to get x times x, which is x squared, x times positive 4, which is plus 4x, x times negative 4, which is negative 4x. Negative 4 times 4 is negative 16. So it equals x squared, those cancel, minus 16. Sketch the graphs of f of x, g of x, and h of x on the same grid. So I know that the vertex of h of x is going to be at 0 and negative 16, just based from grade 11, and from what we've done this year. Because this is just x plus 0 squared minus 16, so I know my vertex is going to be at 0 and negative 16. So I know that I'm going to have to probably change my y scale or else this graph isn't going to work. So I'm going to make my y scale be 4, and I'm going to make my x scale be 1. So it's going to go up by 1s on the x and 4s on the y. So I'm going to draw f of x first. F of x is x minus 4. So I know this is my y-intercept is at negative 4, and I go up 1, right 1, or down 1, left 1, the complete opposite. So I'm going to start at negative 4, 1, 2, 3, 4, because you always start your y-intercept first. Then I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, down 1, left 1. Not the straightest line, but pretend it is. So this is f of x. Okay? Now g of x is x plus 4. So I have a y-intercept at positive 4, and I'm 1 and 1 again. I didn't listen to my own rule. I have a y scale of 4 here. I'm going to change my y scale to 1, just to prove a point. I'll leave my y scale be 1. So I'm going to go up 4, 1, 2, 3, 4. And I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. Because they will be more accurate this way to show you how I get the product h of x. I'll show you. If I go with a scale of 4, it'll be harder for you to see how I'm calculating it. Okay. Now, if you notice, they're actually running at the same slope because they have the same slope. The green one's a little shady of a line, but they're running the same thing. So remember, what do I do whenever I'm doing operations, whether it's addition or subtraction or multiplication or division? What I always do is I keep the same x value and do the operation to the y values. Keep the same x value, do the operation to the y values. The operation that I'm doing right now is multiplication. So if I start off, I always want to compare the graphs where I can actually see both of them. So I'm going to start off at -3. So if I look at -3 here, -3, it's f times g. And now I know multiplication doesn't really matter. If you do g times f or f times g, you get the same thing. But division, it matters. Subtraction, it matters. So it's best to always just do it in the right order. So f times g. So if I go to -3, f is 1, 2, 3, 4, 5, 6, 7. It's -7. And g is 1. So at -3, I have f at 7 and g at 1. Well, 7 times 1 is, or -7 times 1 is -7, so it's going to stay here. Okay? Now I'm going to go to the next one, which is -2. F is -6. G is 2. -6 times 2 is -12, so it's actually going to end up somewhere down here. Like I said, this is going off the graph, but it's just easier to show you how I'm mentally doing the math. Now, if I go to -1, -1, f is at -5, and g is at -3, so that gets me to -15, so somewhere down here. If I go to 0, f is at -4, g is at +4. -4 times +4 is 0 and -16, which is what we said the vertex of h of x is. So we know we're right. See, you can do it by actually drawing the graph. I know this is the weirdest thing because I'm going right off the graph, but I wanted to show you how you can go from these two lines without coming up with the equation first to be able to graph the graph just from two lines, not from the equation. So if I go to 1, f is at -3, g is at 1, 2, 3, 4, 5. So I'm at 1 and -15 again. Do you see how it's making a parabola here? Then if I go to 2, it's at -2 and 1, 2, 3, 4, 5, 6. -2 times 6 is -12, so I'm going to be at 2 and -12, still forming that parabola. And if I go to 3, 3 is at 1, -1, and 7. -1 times 7 is -7. So do you see here how these are going to actually all connect? Oops, pretend that I'm connecting them properly, which I'm not doing very well. And they're going to form that h of x graph, which is x squared minus 16. So I didn't actually need the equation x squared minus 16 in order to graph it. I can use the two original equations to come up with the new graph. So state the domain and range of h of x. H of x has a domain at x arcs. It keeps going on forever to the right and left, as do all quadratics. Or in interval notation, -infinity to +infinity. Range, I have to find my minimum value. Well, I know my minimum y value is at -16 or greater, right? So my range is going to be y such that y is greater than or equal to -16 yer. Or interval notation says -16 to +infinity round bracket. Now we're doing division, or getting an answer to a division, which is quotient. Example 3. Determine h of x equals f of x divided by g of x, then state the domain and range of h of x. The moment you have a quotient, you are going to have non-permissible values for the most part, because you have a denominator. Now sometimes you don't end up with non-permissible values. If in the denominator, for example, you had instead of a difference of squares, you had an addition of squares, so like x squared plus 16. When you go to do your non-permissible values of that, you'd have x squared plus 16 can't equal 0, x squared can't equal -16, and then you go to square root that with a plus or minus sign, but you can't square root a negative number. There's nothing I can fill in to this x value that when I square it, will get this 16 to cancel and become 0. So I would have no non-permissible values here if I had that. on the denominator. So most of the time you'll end up with the denominator when you have that. So let's try this out. H of x equals f of x, which is x plus 3, over g of x, which is 2x minus 5. Okay, I can't simplify that anymore. I can't take GCFs out of them. I can't factor the numerators or the denominators. So that's staying as the way it is. But this brings you back to the rational unit that we just finished. I need to figure out my vertical asymptotes and my horizontal asymptotes because that will give me my domain and range. So my vertical asymptote is going to be x equals 5 over 2. Remember, it comes from your NPVs, solving your denominator. Your horizontal asymptote is going to be at y equals, and because these are the actual same degree, we take, remember, the value of the coefficients in front. So it's going to be y equals a half. So then your domain and range is really easy. The domain is x such that x can't equal 5 halves, because it can equal everything but that, because that's my asymptote where the graph does not exist. And the range is going to be y such that y can't equal a half, because it can equal everything but the horizontal asymptote. Now, consider the functions example 4. Consider the functions f of x equals x squared minus 9, which screams difference of squares, and g of x, which equals x minus 3, which should make you happy because that is one of the factors that's going to come out of the difference of square. So determine the equation of the function h of x equals f of x over g of x. So h of x equals f of x, which is x squared minus 9, over g of x, which is x minus 3. H of x equals, you can factor x squared minus 9 into x plus 3, x minus 3. Now remember, those two cancel off, but don't get too excited. Remember, if it's in the denominator at any point in time, it's going to affect your domain. So remember that if two factors cancel, that gets you a point of discontinuity. You're going to have a point of discontinuity for this one at x equals 3. And how do we find the y again? Remember, now you have y equals x plus 3 left over. Take your value of 3, plug it into the x, and solve for your y. So y equals 3 plus 3, which is 6. So our point of discontinuity is at 3 and 6. So that's the point that doesn't actually exist on the graph. It's that open circle. So our domain and range are easy. I'm going to go to those first. The domain for h of x is going to be x such that x can't equal 3, xer. And the range is going to be y such that y can't equal 6. And now I'm going to show you by drawing the two graphs how you can come up with that actual rational graph without being given the equation. So if I draw f of x on here, this time I'm really going to make the y scale 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to make it be 1. I know this is silly because I'm drawing off of the graph, but it'll just be easier. And then the x scale will be 1 as well. So if I go to draw f of x equals x squared minus 9, I know my vertex, because this is x plus 0 squared minus 9, is at 0 and negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I know when I factor it, I get x plus 3 and x minus 3. So when I solve those, I'm going to get x equals 3 and x equals negative 3. And now I can put way more points on too, especially if I was sketching this from one graph to the other. I'd want to be more accurate, but I'm just doing this quickly. Now, that's going to be your f of x graph. G of x, I'll do it in blue. is x minus 3. So I'm going to go to negative 3, and then I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Now remember, let's think about this. When do we get something undefined? Something is undefined when you divide by 0, right? And whenever we're doing these graphs, what we're doing is we're taking the x values, same x values, finding their corresponding y values and dividing them now. Last time we multiplied them, now we're going to divide them. So for these ones, we're doing f divided by g. So if ever g has a y value of 0, when we divide by that, we're going to get undefined, and that's where we're going to get our asymptotes. So this is g of x here. Okay, asymptotes or points of discontinuity. In this case, we're going to get a point of discontinuity. So, and it's going to be at 3, because this is where g is 0. So what I'm technically doing is at 3 and 6, I'm going to have point of discontinuity. Let's see what else I get. Okay, so here I have 0 as my f, so 0 divided by g, which is 1, 2, 3, 4, 5, 6. So I'm looking at negative 3. It's going to be 0 divided by negative 6. 0 divided by negative 6 is 0, so it just stays here. All right? Then I'm going to go to this negative 9 and this one here, so where x is 0. And I have to do f divided by g. So f is negative 9 divided by g, which is negative 3. Negative 9 divided by negative 3 is positive 3. So now it's going to be at 0 and 3. Right? And so on. So that's how we get that line and that point of discontinuity. Rather than physically drawing the line y equals x plus 3 and then just writing our point of discontinuity because we know that. Because sometimes you're not given the equations, you're just given two lines or a parabola and a line, and you have to come up with the new equation. Now remember, wherever the denominator equation has y equals 0, you're going to get an asymptote or a point of discontinuity. Example 5. Given f of x equals x plus 1, g of x equals 2x plus 1, and h of x equals 2x squared plus 7x plus 3, determine each combined function in states, its domain, and range. So remember, this little dot in between when it's closed means multiplication. So we're going to have y equals f of x times h of x. F of x is x plus 1. H of x is 2x squared plus 7x plus 3. And we're going to distribute. All right. So example number 8. If h of x equals f of x divided by g of x, and f of x is x cubed plus 6x squared plus 11x plus 6, we're using polynomials here, and h of x equals x squared plus 3x plus 2, determine g of x. Okay? Please, you guys, remember how to do synthetic division. If you still don't know how, you have to. That's like the give me easy questions on the diploma. You can't go in not knowing how to do synthetic division. Okay, so let's fill in what we do know. We know h of x is x squared plus 3x plus 2 equals f of x, which is x cubed plus 6x squared plus 11x plus 6 over g of x. And ultimately, we're trying to find g of x. We can bring the g of x up and multiply it, and bring the x squared plus 3x plus 2 down and divide it. So we get g of x equals x cubed plus 6x squared plus 11x plus 6 over x squared plus 3x plus 2. Now, some people could do long division, but that scares a lot of people. So what you might want to do is just factor them and cross off factors that are similar. So in the denominator here, I'm going to factor it, and I'm going to get x plus 2 and x plus 1. If you can't remember how to do synthetic division, you have your calculator. Let's go through it, just because there are some people that I know still don't know how. So we're going to go into our y equals. Remember all the possible roots of x cubed plus 6x squared plus 11x plus 6 are the factors plus or minus of 6. You can always try those out if you didn't have your calculator. Because we do in time constraints, I'm going to do it this way. So x cubed plus 6x squared plus 11x, and then plus 6. And I'm going to go to my table of values, and I'm going to look for an x-intercept. So I have a few. Actually, I have all three here. So I could just go x plus 3, x plus 2, x plus 1 on the top. X plus 3, x plus 2, x plus 1, like this. And I would if this was me. But I want to go through how to do synthetic division just in case you forget. So -1, -2, or -3, I could use either, any of the three. I'm going to use -1 and show you how we do this through synthetic division. So we have to make sure we can count down our polynomials. So we have x cubed, x squared, x, and then constant. So we can count down. So we write the coefficients. 1, 6, 11, 6. Next thing we do is you drop down the 1. We multiply. -1 times 1, -1. 6 plus -1, 5. Multiply. -1 times 5 is -5. Add them, 6. -1 times 6 is -6. Add them to 0. It needs to be a 0 or you pick the wrong number or you're doing synthetic division wrong. Now, it was an x cubed, so what the 1 is going to have behind it is an x squared plus 5x plus 6. Because this -1 here is x equals -1. So the factor to that is actually x plus 1. So if I took x plus 1 and I multiplied it by x squared plus 5x plus 6, I would get back to x cubed plus 6x squared plus 11x plus 6. So I have one factor, which is x plus 1. Then I have to factor the x squared plus 5x plus 6. So I get x plus 2 and x plus 3 when I factor those. So those are my three factors. And I would just put them on the top like I did already. Now I can cancel off the common ones. So this. Normally before you cancel, you state your non-permissible values. So x can't equal -1 or -2. And so g of x has to equal x plus 3. And what's great about these is you can actually plug them back in. You could plug in g of x and you can plug in f of x and see if you get h of x from it. All right. That's just exam questions you can try. So remember, the only way we can compare graphs is if we compare the same x values and do the operations to the y's. So we have 4 and 4. They want to know which of the following points must lie on the graph of PQX. So that's P of x times Q of x. So we're going to look at the same x values multiplying the y's. So 4 and 1 and 4 and 3 is going to become 4 and 1 times 3, which is 3. 7 and 4 and 7 and 6 is going to be 7 and 4 times 6, which is 24. And then 9 and 6 and 9 and 8 is going to become 9 and 6 times 8, which is 48. So which of the following points must lie? 4 and 3. Consider the function f of x equals 6 minus 3x, g of x equals 5 minus 2x if the function f times g of x is written in ax squared plus bx plus c with a minus b plus c. So let's figure it out. F, which is 6 minus 3x, times gx, which is 5 minus 2x. FOIL it out. 6 times 3 is 30. 6 times -2 is -12x. 5 times -3x, -15x. -3 times -2 is positive 6x squared. And so we're going to get, I have in brackets, 6x squared minus 27x, when you combine these two, plus 30. So it's saying in the form ax squared plus bx plus c. So ax squared plus bx plus c. Okay, so I'd have to put a plus sign in between here, the 6x minus 27x. So the 6 is a, the -27 is b, and the c is 30. Now it would be just 27 if they had said ax squared minus bx plus c, then you would just take the 27, but because they have a plus, you take minus sign. So it's going to be a minus b plus c. A is 6 minus b, which is -27, plus c which is 30. So we're going to get 6 plus 27 plus 30, which equals 63. The table below describes the function of f of x, and the graph is g of x. So you have a table and a graph. They're not put together. If h of x equals f of x divided by g of x, then what's h of 3? So we want h of 3. So that means we're replacing all the x's with 3. So we want f of 3 divided by g of 3. Remember, when it's in the brackets, that's just the x value, and they want the corresponding y value that goes with it. So f of 3 is the table. So f of 3 is 6. So when x equals 3, y is 6. They want a corresponding y value. And g of 3, when x equals 3, go up to the graph, y equals 1. And 6 divided by 1 is 6. This one we're going to go through in class because it's easier for me to explain it to you in class than on here because it's a complicated diploma style questions they gave us to show you. We'll do that one in class when you come back. And example 13, given f of x equals x squared minus 7x and g of x equals x minus 2 and h of x equals 2x squared plus x minus divided by x minus 2, determine a simplified equation for j of x. Okay, so j of x equals f of x, which is x squared minus 7x, over g of x, which is x minus 2, plus h of x, which is 2x squared plus x over x minus 2. So they have common denominator, so we can put them together. J of x equals x squared minus 7x plus 2x squared plus x. Remember, if this wasn't a plus sign here and it was a minus sign, you'd have to actually distribute the minus sign into both. You'd have to remember to do that. But distributing a plus sign doesn't change anything. So if we forgot to, it wouldn't be the end of the world, but you are technically distributing a plus sign in. All over x minus 2. And so it equals 3x squared minus 6x, when you collect like terms, 3x squared minus 6x over x minus 2. And then don't forget, you can take a 3x out of the numerator. And when you take a 3x out of x squared, you're left with x. You take a 3x out of negative 6x, you're left with minus 2 over x minus 2. X minus 2's cancel, and you're left with 3x. And technically, you should say x can't equal 2 for restrictions. So there's going to be one more lesson left, which is composition of functions. And then, which I'll do Friday and release to you guys. And then you'll have all of the lessons from 30-1 down, and we're going to review these by doing a whole bunch of question styles. And you guys come back Monday, Tuesday, Wednesday. So I really, really, really want you to watch all 3 and write down the notes, and then we're going to go through them and extra question style on Monday, Tuesday, Wednesday, because your mock is the following Wednesday and diplomas start the following week for English and social, yeah. So here's your assignment right here from the textbook. Hope you're having a great Christmas holidays.